As an exercise in logic programming in GDL, let's look at the outputs of the rule set we just saw at various points during an instance of the game. To start, we can use the rule set to compute the roles of the game. This is simple in the case of tic-tac-toe as they are contained explicitly in the rule set. Now I'll be indicating portions of the rule set in the boxes at the tops of these slides and then the results below them. Similarly, we can compute the possible propositions of the game. Remember that this gives a list of all such propositions. Only a subset of true will be true at any particular state. We can also compute the relevant actions of the game for each player. The extension of the input relation in this case consists of the 20 sentences shown here. The first step in playing or simulating a game is to compute the initial state. We can do this by computing the init relation. As with roles, this is really easy since the initial conditions are explicitly listed in the program, so that need not always be the case. Once we have these conditions, we can turn them into a state description for the first step of the game by asserting that each initial condition is true. Taking this input data and the logic program, we can check whether the state is terminal. In this case, it's not. There are cells containing B, which means it's open and there's no line. We can also compute the goal values of the state. Since the state is non-terminal, there's not much point in doing this, but the description does give values for the state, namely 50 for both white and black, since there's neither a line of X's nor a line of O's. More interestingly, using the state description and the logic program, we can compute the legal actions for the state. The white player has 9 possible actions, marking actions for each of the blank cells, and the black player has just one action, namely no up. Let's suppose that the white player chooses the first legal action, mark 1-1, and the black player chooses its sole legal action, no up. This gives us a little data set like the one shown here. Now, combining this data set with the state description and the logic program, we can compute what must be true in the next state. For example, using the first update rule and the first does fact, we can conclude the first fact about the next state, namely that there will be an X in cell 1-1. And in similar manner, we can compute the various other propositions that must be true in the successive state. All right, now to produce a description for the resulting state from next, we substitute true for next in each of these sentences and repeat the process. And this continues until we encounter a state that's terminal, at which point we can compute the goals of the players in a similar manner.